Scheme doesn't have a for statement. Now it will. We're going to create a for macro. We'd like to define a macro that evaluates an expression for each value in a sequence. For example, if I say for x in 2, 3, 4, 5, square x, I should get the squares of 2, 3, 4, and 5. How convenient. We'll build this macro in 2 steps. First, we define what it means to map a function over values. If values is null, there's nothing in the mapped list. Otherwise, we cons applying fun to the car of vals to whatever we get when we map that function over the cdr of vals. And in this case, we would be able to produce something like the for statement just using map, but it requires a little bit more work. I have to say map, and then I have to give a lambda expression in order to capture this body, and then I have to say what I want to apply it to. So having a for expression in the language doesn't mean I can do new things. It just means it's much more straightforward to state what I want because I don't have to explicitly write out the word lambda. So defining the macro means saying what happens when you have for and then a symbol and then some values and then an expression to evaluate for each of those values. What we do is build this expression. It's a list containing map. It then contains lambda x and then that expression. And finally, it contains the values. Spend a moment and see if you can write out the general macro definition of for that allows us to transform these 3 expressions into this one long map expression. I'll show you the answer in 3, 2, 1. There it is. We build a list that starts with lambda and then has the symbol that I'm using as a placeholder for every value. That has to go inside a list because that's how lambda expressions work. Now expr will be bound to this whole thing times xx, and so I just place that into the lambda expression that I'm constructing as a list. And finally, I write down the values, and then when I run this here, for these 3 expressions, I will build this map expression and then evaluate it, and I'll get the result for 9, 16, 25. So there's another way in which you can extend the syntax of the language, mixing together something that gets evaluated, something that never gets evaluated is just the symbol to use as a placeholder, and then an expression here that gets evaluated for every element of this list. And now we've discovered that Scheme has for statements after all.